this is assignment 3-4. That is on implicit differentiation. So let's look at that. So implicit differentiation means that the equation's not given in an explicit form, which would mean y equals, which would make all the other rules easier to do. But we need a special rules to do when the x's and the y's are kind of jumbled together like this. So the simple rule is that you have to know what you're taking the derivative with respect to. And in this case, most of the time it'll be respect to x. Sometimes it'll be in terms of time, but this is in terms of x. And so if I want to find y prime, the derivative of x squared is 2x. The derivative of y squared is 2y. But because we're taking the derivative with respect to x, every time you take the derivative with respect to y, it needs a hook, y prime. And then the derivative of 4 is 0. Next, you're going to get y prime by itself. So we're going to subtract 2x. We're going to divide by 2y. And when you divide by 2y, the 2's divide out, and you get negative x over y. And you found it. Let's look at number 2. For number 2, you have x times y equals 7. Sometimes you have to recognize that when you're doing these implicit situations, that x and y beside each other, that means they're multiplying. This requires the product rule to do the derivative of. So the product rule is the first times the derivative of the second. Now the derivative of the second is 1, but it needs the hook, y prime, because we took the derivative of y with it. Plus the second times the derivative of the first. X does not need that hook. And then the derivative of 7 is 0. Now all we need to do is get y prime by itself, and you've answered it. So we're going to subtract y prime, or y, to the other side, and then we're going to divide. Number 3. Lift this up just a little bit. So in number 3, we have the square root of x plus the square root of y equals 9. I want to take the derivative of that implicitly because the x's and the y's are jumbled together, and it's a little challenging to get y by itself. So we're going to write this calculus friendly. So to the exponent 1/2. Then when we take the derivative, what we need to remember is if the derivative has a y in it, it needs the hook, y prime. Otherwise, it's just what we've been doing. So the power rule, that's 1/2. Subtract 1 from the exponent. 1/2, subtract 1 from the exponent. Because we're taking the derivative with y in it, it needs a y prime, and the derivative of 9 is 0. Now we need to have the algebra skills to get y prime by itself. So we're going to make this hopefully simple. We're going to subtract 1/2 x to the negative half. Then we're going to divide. And if you want to, after you divide, you can also simplify. So what simplifies here, the 1/2's divide out. And if you want to, and if you recognize the negative exponent actually means it goes to the numerator. So if you wanted to simplify this, it would actually end up being the square root of y on top. So the y to the negative half, that actually means it's the reciprocal. This x to the negative half means the reciprocal. Another way you could write this, all mean the same thing. But this is a great answer, and you can leave it there. Number 4. In number 4, you have y squared equals x divided by x plus 1. Now, to take the derivative of this, we're going to take the derivative of y squared, which is 2y, and then we have a y prime that needs to be attached to it. Then on the right side, I want you to notice that we have the quotient rule that we'll need to do to take the derivative of x. So the quotient rule, big healthy fraction line, it's the denominator times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. Now, this isn't over yet until y prime is by itself. So to get y prime by itself, we're going to divide by 2y. Honestly, I could also simplify the numerator quite a bit as well. But recognize that when you divide by 2y, it's going to join, these are going to join together in the denominator. Notice if I wanted to, x times 1, subtract x, just leaves me with 1. And you did it. Now notice many times when you take the derivative here that you're going to end up with x and y in your answer, which is a little bit awkward, maybe uncomfortable at first, but just recognize that's an okay way to write the derivative, having both x and y in it. Alright, so this is actually also a bit of an experiment to see, having my face and trying to figure it out. I have new headphones, trying to make sure they work. We'll see. So I tried. I'm going to do a video for the first 4 questions and see if they worked. So we'll see. Or I might have to do this video all over again. We'll see. I didn't want to go too far. Anyway, Mr. G Math over and out. I am proud of you for doing your work. And until next time.